Hello and welcome. In this video, I'm going to go over two stoichiometry questions. The first is a mole-to-mole stoichiometry question, and the second one is one that is asking you instead for mass in grams. Okay, let's start. So here's a question just copied and pasted from a quiz check-in that I had posted earlier. Right, that should be fine. All right, so you need to make sure whenever you begin a stoichiometry question that your reaction is balanced. This is not, so that could be your first possible mistake. So balance your reaction. Let's do that now. So the balanced reaction will look like this. Okay. Now let's organize information given to us. We see that it's asking for the number of moles of potassium chlorate. Okay, so moles. I'd like to use the balanced equation as if it were a table to organize my information. So here it says we need to figure out the number of moles of potassium chlorate. So how many moles of potassium chlorate are needed to produce 15 moles of oxygen? Okay, so here's oxygen, and we need 15 moles of that. How many do we need of our reactant? How many moles of our reactant do we need to produce these many moles of oxygen? Okay, so we need to go then from moles of oxygen to moles of potassium chlorate. And to do that, we need to use a mole ratio. In this case, the mole ratio is 3:2. So a factor label setup would work great here. Let's write the number we need, the number of moles of KClO3. Write an equal sign, then write what you're given. So we're given 15 moles of O2, right, straight from the question. And multiply that by a conversion factor, put the unit you want to get rid of at the bottom, that's mole O2, and the unit you want to keep, which is mole of KClO3. So mole of KClO3 at the top. Now this conversion factor we know to be our mole ratio, and it's making reference then to the coefficients in the balanced equation. So 2 appears in front of KClO3, we write a 2 here. 3 appears in front of O2, so we write a 3 here. Notice our units cancel out as they should. And what we're doing then is 15 times 2 divided by 3, and we get 10. Okay, you can have a therefore statement then. Therefore, you need 10 moles of KClO3 to produce 15 moles of O2. And you're done. Right, so this is your final answer. Next question. What mass of magnesium oxide is produced from 2 moles of magnesium? Now, in the quiz that you had online, I'm just giving you direction here to not write the unit so that my answer would match yours and you would get it right on the practice quiz. Okay, again, you always want to make sure that you are balancing before you start, right? So that means a balanced equation would look like this. Right, and you're done. And again, use this, entirely up to you, but I find it works really well. Use this balanced equation as if it were a table to organize the information given to you. So let's read the question, what mass? Okay, so it's asking us for mass. So what mass of magnesium oxide? That's here. So we don't know that, that's the question. Is produced from 2 moles of magnesium, right? So we have 2 moles of magnesium. Okay, so 2 moles of magnesium in this equation. Very good. Okay, so in order to obtain the mass of something, we need to use moles. In this case, we're given moles. So we're going to go from moles of one to moles of another, right? And that's stoichiometry. And in this case, we have a 2:2 ratio or a 1:1. Now, I've only done this a few times for you to see, but this is a good question to review because it's a 1:1 ratio. And although a factorial method would work great, you actually don't need to. Proportion method would work great as well, but you do have another option that might be a bit more appealing. Okay, so we can say, using since and therefore statements, we can say since magnesium to magnesium oxide is a 1:1 ratio, therefore the number of moles of magnesium is going to be equal to the number of moles of magnesium oxide. Therefore, we get number of moles of MgO equal to 2. That's it, right? That's all we needed. Now we have the number of moles of magnesium oxide. It's 2, right? Since it's 1 to 1. And as long as you show in some way using a proportion method, a since and therefore statement, or a fact table method, showing the logic behind why this is happening and a process, then you're fine. You're set to do that and you're ready to move on to the next step. Now, the next step, it's not asking us for moles like the previous question was, it's asking us to figure out what the mass of magnesium oxide is. So we can say mass is equal to moles times molar mass. Of course, I'm using the formula here, but you can use fact table method and it would work just fine. All right, so we have 2 moles of magnesium oxide. The molar mass of magnesium oxide is 40.3 grams per mole, roughly, right? And you should get 80.6 moles as your final answer. Okay, so that concludes our 2 questions. The next video, we'll then get into questions that look at limiting reagent type questions. Hope this helps.